Here are the notes for 6-5. This is about trapezoids and kites, and in particular isosceles trapezoids. So before we go into the theorems at the top, let's go to the middle right here, this picture here. This is an isosceles trapezoid, or this is just a trapezoid actually. And the sides that are parallel are called the bases. There's two sides that are parallel in any trapezoid. And the other sides that are not parallel are called the legs. And these angles at each of the base are called base angles. The two at the top that connect this top base, and then the two at the bottom are called base angles. All right, let's now go back to the top part. Theorem 6-5. The base angles of an isosceles trapezoid, now it has to be isosceles trapezoid, are congruent. They don't give you a picture, so I try to just sketch a picture here. This is the two parallel bases, isosceles. Those two sides are equal. Well, the base angles of this isosceles trapezoid are congruent, so that means this angle is equal to this base angle. This top obtuse angle is equal to this top base angle at the top. So the two base angles and then the two bottom base angles are equal. Okay. There's another theorem about isosceles trapezoids. Again, it has to be isosceles trapezoid where parallel, parallel, equal, equal. And again, I just drew this just to demonstrate it. The diagonals of an isosceles trapezoid are congruent. So if I take a ruler and go one corner to one corner, measure that, maybe that's 5 inches, one corner to another corner, that would also be 5 inches. So in this picture, AC would be equal to BD all the way across. They don't bisect each other. They're not 90 degrees in the middle, but all the way across is equal to all the way across. That's for isosceles trapezoids. And again, it just says trapezoids, but really it's all about isosceles trapezoid. The next theorem here is about kites. They don't have a picture, so I kind of just sketched some kites here. The diagonals of a kite are perpendicular, so that's 90 degrees. So if I just go corner to corner here on this kite, corner to corner here on this kite, you'll see that it's 90 degrees perpendicular in the middle. Okay. Now with a kite, there's also some other little things that occur, but they're not really flat out theorems. For example, if you'll notice, this angle on the left is equal to this angle on the right, but this angle at the top is not the same as this angle down here at the bottom. Okay, so there's one pair of equal opposite angles, but not the other pair. Also, with a kite, if you draw, let me see if I can just draw this, another kite here. If you draw the diagonals, you'll notice that one diagonal bisects the other, but not both. They don't both bisect each other. What I mean by that is I'll draw this long diagonal this way, and this shorter one going left to right. Not only is it 90 degrees in the middle, this left is equal to this right. But obviously this top part of the diagonal is not equal to the bottom part. But the left is equal to the right, and then also the angles are, one pair of opposite angles are equal. But that's not a theorem, but it does actually occur. Okay, so let's deal with figuring out angle measurements for an isosceles trapezoid, and then later on for a kite here. This is an isosceles trapezoid, so parallel, parallel. The sides that are equal are the legs. These are the base angles. If it's 70 here, it's 70 here. The base angles are congruent. Now that doesn't mean this is 70. Because these are parallel lines, this dot and this dot are same side interior, and they add to 180. So this angle P here is 110, because 110 plus 70 is 180. This angle Q is also 110. And 110 and 70 forces the two lines to be parallel. Thus it's a trapezoid. Okay, let's look at the kite here. We're going to figure out the measurement of angle 1, angle 2, and angle 3. Angle 1, because it's the diagonal, it means right where the diagonals intercept. In a kite, it's 90 degrees. It's perpendicular, so that's 90 degrees. Angle 2 here, this diagonal splits this in half, so this is actually 46. And now this is not 46. You got to focus in on this triangle down here for angle 3. You've got a 90 degree, I'm just blowing this up, angle 2 here, which is 46, and then angle 3 here, it's 180 minus the 90 minus 46 is equal to 44 degrees. So this is 44 degrees here, 44 degrees. Okay, and that is it.